Hi everyone, I'm Enshan. I'm a postdoc working in our X-Car City project, and I'm part of the Summer Lab. I'm currently working on a federated digital twin for assessing user experience. So first of all, we wanted to build this digital twin to support decision makings of stakeholders. Well, stakeholders can intervene the urban system through design, management, and policy. They can change the mobility system, they can change the functions of buildings and locations. But how can we know the impact of these interventions? For example, what's the impact of using mixed-use strategy during the design and planning stage? Therefore, we need a digital twin to help us assess that. So this is a web interface demo of our digital twin. We wanted to visualize the different types of data, like the buildings, the road network, the traffic flow, and a heat map of some quality. This quality can be like a safety score across the area. We will also have a time slider so we can see the different situations at a different time. Well, this is part of our digital twin, a pedestrian model. We build a pedestrian model that can predict the travel demand and the pedestrian flow, as you can see here. It is applicable so this pedestrian model can be combined with other vehicle traffic models together. So we will have a multi-model traffic simulation of the whole system. This model, as you can see, is applicable at the district level. But we will also make the digital twin to be able to zoom in so we can see more details at finer spatial temporal resolution, and we will assess different kinds of qualities: safety, congestion, comfort, visual experience. So this digital twin will be applicable at different, will be applicable for diverse qualities. It is sensitive to different spatial design alternatives, sensitive to temporal fluctuations in the flow. It also can be applicable at different spatial scales. We can even zoom in to see details on building or intersection level. This is a framework that I used to structure the digital twin. So the input data of this digital twin are design alternatives, and the output of this digital twin is are the different kind of mappings of different qualities. Within this digital twin, we have theoretical frameworks. We have indicators to measure those different quality, different values. We have digital methods and tools to simulate, to visualize. This is another way to see this digital twin. So we we integrate all kinds of data of different aspects and modalities at a different scale. Then we can simulate the whole system. The first step is simulate the mobility, so we can have a foundation of this system. In terms of the assessment, we have more content relates to user experience. So we wanted to assess the user experience. As human users, we experience the urban environment in a multi-sensory way. We can move, we can smell, we can see, we can feel the wind, the heat. Therefore, our digital twin needs to simulate these different features of the urban environment. And luckily, we have there's many existing models to simulate all these aspects like noise, wind, sunlight, pollution. In our project, we categorize the metrics, the user experience in 3 categories. One is accessibility. The second is health-related qualities. The third is about visual attractiveness. So by simulating them, assessing all these, I think we will have a comprehensive assessment of user experience. The technical way I simulated the system and assess is using agent-based simulation. We simulate thousands of people as agents in this environment. They interact with the environment, so they can have perceived or measurable value of the environment, so they can see whether this design of this environment is good or not. So this is basically a movement simulation, but we also want to dive into visual simulation. So right on this slide, this little tiny guy can see the image in the middle. In his eyes, he can see this. Then we use some mathematical models to calculate some quality based on the visual features in the image. We have one score of some quality, for example, safety or visual attractiveness. If we calculate every point across this area, we will have a map of some quality of this area. So that's how we do this assessment. Okay, that's all. Thank you.